All right, in this section on 3.4, we're going to talk about both linear speed and angular speed and apply those in a situation. So let's first kind of discuss linear speed. Here's a formal definition of linear speed, and what this is basically saying is that when we talk about linear speed, we're talking about how fast the speed at which p is traveling around the circle. Okay, so if you think of speed, speed is generally listed as velocity. Our cars, they travel at a speed of miles per hour, right? So that's a rate, a distance versus time. So when we're talking about the linear speed is along the outside of the circle, and it is the speed or the rate at which p is traveling along this line on the outside of the circle. Okay, now let's talk about angular speed because they're different. Angular speed is still a rate. Okay, it is still a rate for time. And what we're talking about for angular speed is as p moves around, theta, the angle theta is changing. So as p keeps moving around, this angle theta is changing. And so we represent that as theta with respect to time. Okay? And it's always listed in radians, just like it was in arc length, area of a sector, that kind of stuff. We need to make sure we're in radians. Okay, so the difference here is p is traveling along the outside of the circle, and that's what the speed is. Here we're talking about the speed that theta is changing. How fast, what is the rate at which theta is changing? So now that we have an idea of what these two terms mean, let's kind of summarize their formal formulas here. Okay, so angular speed again is represented as W equals theta over time, where theta is in radians. So when we look at this, the units on it would be radians per time. Okay, and then linear speed, it looks like there's a lot of formulas here, but they're really just one formula in different forms. So if we know that the velocity is the distance over time, we can rewrite that knowing that s, remember s was our arc length, so we can replace s with r theta. And also we know theta over t is actually w, so we could write velocity in this way too. So really it just depends on what it is what information you're given in your problem you're trying to solve for. So let's apply this with this example right here. So this one says, okay, we have p. We suppose that we have p on a circle that has a radius of 10 inches. And as that ray, or in other words, as p is rotating around the circle, it's going to rotate at an angular speed of pi over 12 radians per second. The very first thing I'm asked to do here is to find the angle generated by p in 10 seconds. What I want to do when I approach these problems is I first want to start writing down what information am I given. In the very first paragraph here, I know that the radius is 10 inches, so I'm going to start by making a list. And I know that the angular speed is pi over 12. So that's that right there. W is pi over 12 radians per second. And finally, I know that in this first example 1a, I want to know what the angle generated is when I'm given time as 10 seconds. So I want to know what is the angle generated. So I'm trying to find, I'm looking for theta. So if I know all of this information right here, I can find theta by remembering that, well, I know the angular speed, and that's given by theta over time. Okay? And because I know two of the three items out of this formula, right? I know angular speed, I know time, then this formula is going to help me that I have all the information I need to be able to solve for theta. So now we're just going to replace our known values. So let's rewrite this. So W is pi over 12 equals theta over time, which is 10 seconds. So we solve this. There's a couple of different ways we can do it. The easiest is to just cross multiply. When I cross multiply, I'm going to get 12 theta is equal to 10 pi. Divide both sides by 12. Theta would be 10 pi over 12, or reducing that fraction, we get 5 pi over 6, and I know this is radians. Okay, so now we have figured out what theta is. I know R, W, T, and theta. This part of the question says, well, what is the distance traveled by P along the circle in those 10 seconds? So distance traveled, what they're actually asking me for is S. So what is S? Well, S we can find several different ways, but I do know what theta is, and I know what R is, so I can use the formula for the arc length, theta times the radius, and let's substitute in. So S equals 5 pi over 6, because that's theta, times the radius of 10. Now we're going to multiply these two things together. Remember, when I'm multiplying fractions, that 6 is going to go into that. There's a 2 that goes into both of those numbers, so I get a 3 and a 5. So the answer is 25 pi over 3, and that would be inches, because we are traveling, we have a distance in inches. Okay, so you always want to give back your answers in reduced fraction form, and I didn't specify in this example, but I'm pretty sure in your homework you would be, in order to leave, when you'll know to leave pi in the numerator when you're told that you need an exact answer, just to re-emphasize that. Now the last part of this says, okay, what is the linear speed? Linear speed. Now linear speed was given by several different formulas. Velocity is equal to S divided by T. It's also equal to R theta divided by T. And finally, it's equal to RW. It doesn't really matter which one of these formulas that we use at this point, because this question comes at the end of all the information we have found. We know S, T, R, theta, and W. So I can use any of these three formulas and I'm going to come up with the exact same answer. So let's look at this formula right here. I have velocity is equal to the length divided by time. So if I used that formula right there, I know that the length is 25 pi over 3. And I'm going to be dividing that by the time, which was 10 seconds. Okay, now this is a complex fraction. Remember that if I have a complex fraction like this, what am I really doing? I have a number divided by another number. When I divide fractions, I keep the first, okay, keep the first number, change the sign to multiplication, and flip the second number. That's the 10. So the 10 flipped, or the reciprocal of 10, would be 1 over 10. Okay, so now we have two fractions we can multiply together. I know that 10 and that 25 are going to reduce because 5 goes into both of those. So my answer should be 5 pi over 6. So let's just see, if I had tried it using the radius, if I had tried it using the this formula here, radius theta over time, let's just make sure we get the right number. I just have to make sure I get those right variables. Let's see, the radius is 10 inches. Theta is 5 pi over 6. Time is 10 seconds. Okay, so we have, again, a complex fraction going on here. So I'm going to simplify my numerator by saying 2 goes into both of those. That's a 3 and that's a 5. So my numerator should now look like 25 pi over 3 divided by the 10 seconds. Again, that's the same thing we had up there. We know this is 5 pi over 6. And it should be, what, inches per second. Okay. Now let's just look at this one down here, just to make sure. The radius we knew was 10 inches. The angular speed was given to us at pi over 12. When I multiply these two together, I'm going to reduce before I do it, because I know there's a 2 that goes into both of those. That's a 5, that's a 6. And sure enough, I get the exact same answer. So I just wanted to point out to you, it didn't matter in this case. It didn't really matter which one of these 3 formulas I used, because I knew all of these variables coming down to this particular question. So when you're faced with the choice of which one do I use, you want to ask yourself, well, which one of these formulas do I know the most information about? In this particular case, I knew everything about all 3 forms. Now, the other thing I wanted to make sure that you understand is how to simplify or how to approach this complex fraction. So you take the numerator divided by the denominator, and when we are dividing fractions, we are multiplying by their reciprocals. So that's just a review of that. Okay, so we'll stop here and we'll look at the modeling on the next video.